In this problem, as we convert from standard to vertex, you will notice that the A is not 1. Again, the first step that I like to do is I like to move my constant, minus 25 in this case, down, and I just leave that alone for now. The next step that we have to do is we have to factor out a 5 to make this a 1x squared. So when I factor out a 5 only from the quadratic and linear terms, I am left with x squared minus 4x. I'm going to leave space to create my perfect square trinomial. I'm going to bring down the minus 25. So to make a perfect square trinomial, we take half of 4, which is 2, and we square it, and we get 4. So we have a perfect square trinomial. However, we just added in a 4, but what value was really added to this side of the equation is 5 times 4, which is 20. So if we add a 20, we also have to subtract a 20. That gives us an actual value of 0. Bring down your 5, factor the perfect square trinomial. I'm going to take the root of my quadratic term, the sine of my linear term, and the root of my constant term. I am going to combine the negative 25 and the negative 20. And now I have converted to vertex form. The vertex is going to be the opposite of this h value, 2, and it's going to be the actual value of the k, which is negative 45. So we have a vertex of 2, negative 45. We also notice that the a is positive, so our quadratic will look something like over 2 and way down at 45, and it does curve up, and we would have 2 real roots.